Alright, so today we're going to continue talking about graphs of the sine and cosine functions. Here's your header. Again, it's on your paper as well. 6.4, page 408, number 3 through 8, 10 to 20 even, 21 to 34 all, 36 to 52 every other even, which are going to be on graph paper, and 60 to 72 even. Okay, so let's get started. Number 3 is our first one. This is in your vocab section, and it's asking what the maximum of sine is. The maximum of sine. The first thing you need to remember when you're on your calculator graphing is that you need to be in radian mode, not degree mode. So we're adding our graph, and I'm in radian mode. I press trig and sine and x. So this is what it's supposed to look like in radian mode. If you were in degree mode, it would look flat, which is wrong. So make sure you're in radian mode. You can also manipulate the trig window by going to window and then 8. That goes from -2 pi to 2 pi and from -4 approximately to 4. And there's a whole bunch of other videos that talk about settings for your table. Just real briefly, Control T. Most of these numbers aren't going to make sense except for the 0, 0. So that's why you would go to edit your table settings and either go to ask, where it leaves it blank, and then you put in whatever you want, 0, pi halves, pi fourths, whatever you want. Or you could go to your table and go to your settings, start it at 0, and then step by a certain thing like pi halves, pi fourths, whatever you want. So if I go pi fourths, looks like this. Just as a quick reminder, if you see e with a negative exponent like that, that should indicate that it's really 0. Okay? And if it's e with a positive exponent, it would be like infinity. So anyway, the maximum of sine is 1. It's 1. And it happens at pi halves in the interval 0 less than or equal to x less than or equal to 2 pi. So this is the y value, this is the x value, and this is your interval. So in my graph, I'm showing 2 periods worth like we do on our graph paper, but you could just set this to be 0. And now you're showing 1 period worth from 0 to 2 pi. And so the maximum occurs at the high point, which is at pi halves for x and 1 for y. Alright, number 4. On this one we have our equation y equal a sine wx, which has amplitude 3 and period 2. It wants to know what are A and W. So the A part is the amplitude. That's the easy part, which is just 3. If you put W is 2, you'd be wrong. What you need to remember is there are a couple of different formulas. We have period as the normal period divided by W, or if you've solved for W already, it's the normal period divided by T. So you can use either of those two formulas. Our period is the t, so we could plug in 2 here. Since all of the normal periods are 2 pi, except for tan and cotan, we can plug that in here and then solve. You could take steps with this and multiply by w. So you get 2w equal 2 pi, and then divide by 2 like that. So w is pi. Or if you use this formula, you just get it with 2 pi divided by 2, which is pi. So this is the way I prefer, but if you'd rather just plug in first and then solve for variable w, you can. Whichever way you want to work. So the next step would be to write your formula, which would be based on a wx, so that'd be 3 times pi x. So that's your answer. Our next one's number 5. This one says y equal 3 cosine 6x, and again it's asking what are a and w. So again, our a is the number in front, our w is 6. It's actually asking what are a and t in this one. What are a and t? So it's giving you your w, which is 6, and so our t would be our normal period divided by w, so that's 2 pi divided by 6, and remember to reduce that to pi thirds. If they're even, you just divide by 2. So pi thirds. So think about when it's pi thirds, your graph is going to repeat more often because it's more frequent. So if we compare those two, the first one should be 3 sine pi x. I left off my sine right there. My bad. So we have 3 sine pi x. Okay, so there it is. And again, we want our window trig like this. Then if we press tab and go to the other one, we're going to have 3 cosine 6x. And so that's even more frequent. Okay, number 6. What we have is a true-false question, which is saying graphs of the cosine and sine. Graphs of cosine and sine are identical except a horizontal shift. True or false. So again, to answer this, we could go to our graph. Sine x looks like this. Cosine x looks like this. And so it does appear to be true. If you shift one of them to the right by putting like a plus, plus means minus. If you put plus pi halves, Well, that one made it look more like a chain link, so it looks like we have to change sine to be that. So we want to leave this one alone, and we want to change our sine graph to be pi halves units over. And then, whoops, let me just change this one from a minus to a plus. There. So now you can see that it is true. So sometimes you have to work through things to understand it. And this one is y equal cosine x is the same as y equals sine x plus pi halves. So when you shift sine left, then it's the same as cosine. Any questions? Okay, number 7. Another true-false question. If you have y equal 2 sine pi x has amplitude 2 and the period pi halves, question mark. Is that true or false? So our amplitude is 2, our w is pi. So far at this point, our amplitude matches what the question has, and we got to figure out, is our period pi halves or something else. So what we know is our w is pi, so our formula is period is your normal period divided by w. So in this case your pi's cancel, so you get 2. 2 is obviously not the same as pi halves, and so this would be false. And number 8, another true-false question which says there are infinitely many, by the way, the spelling of infinite doesn't have an A in it, infinitely many x-intercepts for sine and cosine. This one is true. What we see is if you zoom out or just change your window, like by clicking here, change it from 10 to 100, you have even more x-intercepts, and so that's an infinite number. So that's number 8. Now, number 10, this is one of the longest questions. There are 7 questions related to cosine. There's another one from the book that has 7 questions related to sine, but we're just doing the cosine one. So before we get started, we need to refer to it knowing that it's an even function and looks like this. So this is the ordered pair 0, 1, and this is at pi halves. This one's at 3 pi halves. Okay, so that's our graph. The first one for this says, what is the y-intercept? And it's asking for the 1. As an ordered pair, it's 0, 1, but the math Excel would just want the number or integer. The next one, and several of these, what you have to do is pay attention to your intervals, because you're going to have to change your intervals quite a bit on this. For B, it wants to know for what numbers on negative pi to pi is it decreasing? So if it's negative pi to pi, that would indicate this ordered pair is pi comma negative 1, and so from negative pi to pi, negative pi comma negative 1, that means we would cover up this part, and so it's decreasing where it's like negative slope, so that'd be from 0 to pi. And remember, for this answer, we don't want the equal part, we just want the less than. So that's basically from 0 down, because that's sort of like negative slope. And remember, don't use less than or equal to. Okay, the next one wants to know what the absolute minimum is. And that'd be negative 1 since it's the lowest y. The next one says, when is g of x equal to 0 on 0 less than or equal to x less than or equal to 2 pi. So what we notice here is you cover up the left side, and then just talking about here to here. And when is it equal to 0 means when does it have x-intercepts, which are pi halves and 3 pi halves. Pi halves, 3 pi halves. The next one says, when is g of x equal to 1? This time they give you a larger interval. Negative 2 pi less than or equal to x less than or equal to 2 pi. So in this case, the whole thing. So where it's equal to 1 is at this part, and 0 in this part, so that'd be 0 and plus and minus 2 pi. 0 and plus and minus 2 pi. F says, when is g of x? When is g of x equal to square root of 3 over 2? So remember, from your unit circle, it does equal that sometimes. Square root of 3 over 2 comma half. So if you remember what I've said before, the sine of 30 degrees is the only one I have memorized, and it's at a half. So 30 degrees, because this is the cosine and this is the sine. So you can get that from your unit circle. We do need the exact answer. So let's work through this as if you didn't remember from the unit circle. So what you would do is you would say the first function would be cosine x. The second function, f1 of x, is cosine x. f2 of x would be square root of 3 over 2. Okay, so let's start fresh. We want cosine x, and we also want square root of 3 over 2. Okay, so there it touches. On your calculator, when you do this, you're going to get a decimal, but sometimes we want to work towards that so that we know we're correct. By the way, if you wanted to get your maximum and minimum this way, that were -1 and 1, you could. What I want is the intersection. Let's just say from here to here, and just move this. And drop it. Okay, so this is my first positive occurrence. My first positive occurrence, which means after the y-axis, and that is 0.523598 something for x. The y value is 0.866, which is what square root of 2 over 2 is. Square root of 3 over 2. So we know that's our first positive occurrence, and now we need our second one. Go to Analyze Graph, intersection between here and here. It's at 5.76. So the second one is 5.76 approximately. 7595. Okay. So that's going to be a little helpful, but we can't type that in MathXL and get it correct. What we do is we can try different things with pi, like try pi over different numbers. If we try pi over 6, pi over 6, control enter, that does give me what we want. So that works. So pi over 6 works. Now the other one, basically if you remember on your unit circle, you're going 30 degrees up, which is pi 6. If you go down pi 6, you'll have the same x value. This will be a negative a half. This one would be a positive a half. So your x or cosine answers are the same. Now obviously this is not a negative number, but if you do your 2 pi minus pi 6, let's see, you have a 6 here, so we need to make that 12 pi over 6 minus pi over 6. That's 11 pi over 6. Pi over 6, control enter. Sure enough, it does give us the 5.759 that we were looking at. So that means that our answer, since it's symmetric to the y-axis, is our answer for F is plus and minus pi 6 and plus and minus 11 pi 6. So it didn't just happen at one occurrence, it happened down here, and also plus and minus 11 pi 6. So remember, it's symmetric to the axis. So this one right there would be a negative 0.52, and this one over here would be a negative 5.75. So those are our correct answers. Since it's symmetric to the y-axis. That's how come we can just put plus and minus. Alright, our next one has to do with the x-intercept. And we answered this already. It was plus and minus pi halves and plus and minus 3 pi halves. Now, what's a bit tricky on this is it has a different format on the Math Excel. It wants you to choose the correct pattern. And sometimes it says plus and minus pi k or 2 pi k or not necessarily plus and minus, but x equal 2k plus 1 over 2 times pi, and another one would just be something like k plus 1 over 2 times pi. So we need to choose the correct pattern. So what you can do is you can plug in 0, 1, and 2 for k and rule out choices. For the first one, if we put in 0 for here, it'd just be 0, which is wrong because we're expecting pi halves. Same thing for this one. But if we put in a 0 here, we get 2 times 0 plus 1 over 2 times pi. So the 2 times 0 cancels, and you get a half pi, which is pi halves, which works. So that one is good. We also need to try this one. We can say 0 plus 1 over 2 times pi. So this one would also be pi halves, which works. So because of that, we need to plug in a couple more values and see whether it works or not. So let's try 1 for this. So when we try 2 times 1 plus 1 over 2, that's going to be 3 halves, and so 3 pi halves. On the other one, when we plug in a 1, it'd be 1 plus 1 over 2 times pi. So that one will not work because that ends up just being pi, which is not right. Remember, we were expecting a 3 pi halves, and that's what we got. And so it's this one. So the way we write that is the set of all x's such that x equal 2k plus 1 over 2, all of that times pi. Remember, just as a quick side note, the pattern for odds would be multiply by an even number, then add or subtract an odd number. And then step 3 is just divide by 2. So for example, 2k plus 1 over 2, 2k minus 1 over 2, you can even say 4k minus 3 over 2, etc. All of these are odd number patterns, they just have different starting points. These are odd patterns with different starting points that are different. Okay. So the main part to write would be this as well as the pattern. The set of all x's such that x is 2k plus 1 over 2 times pi. So again, plug in 0, 1, and 2 like we did here. So you can write this part also. 2k plus 1 over 2 times pi, so 2 times 0 plus 1 over 2 times pi, which worked. 2 times 1 plus 1 over 2, which is 3 halves. And we got to multiply that by pi. So 3 pi halves. Okay, our next part we have is shorter. These are about the amplitude and the period without graphing it. So this one we have y equal 3 cosine x, and so our amplitude would be 3, our w is 1, which means our period would be 2 pi over 1, which is simply 2 pi. So amplitude 3 and period 2 pi. Remember, if there's no number in front of the x, think of it as 1. So this would have a normal period of 2 pi. Our next one's number 14. We have y equal negative sine 1/2 x. So don't be tempted to put amplitude as -1 because that's wrong. Amplitude is a distance, so you need the absolute value of -1, which is +1. So you could just put 1 there for amplitude. And our w is 1/2, so our period would be 2 pi over 1/2. Remember, you multiply your extremes, and the 1 times your 1 gives you 4 pi. So that one we'd consider, it's a longer wave. It's a longer wave. What we do know is because of this minus sign, it reflects the x-axis. And our distance is positive, which is why we have to have a +1. All right, number 16, y equal -3 cosine 3x. So again, our amplitude is the absolute value of -3, which is 3. Our w is 3, which means our period would be 2 pi thirds. So again, it'd be more frequent. The next one, number 18, y is 4/3 sine 2/3 x. So our amplitude is 4/3. It doesn't matter if it's capital or lowercase, but our amplitude's the number in front. Our w is 2/3, which makes our period 2 pi over 2/3. And again, think of this as pi over 1. That would give you 2 pi times 3 is 6 pi over 2, which gives you 3 pi. 3 pi. Okay. Next we have number 20. Y is 9/5 cosine -3 pi halves x. 9/5 cosine -3 pi halves x. So our amplitude is the number in front, 9/5. Our w, I've seen different pre-calculus books and trigonometry books that sometimes have w as negative, sometimes as positive. So we can either put this as -3 pi halves or +3 pi halves. The important thing is the period t must be positive. So when we're doing our t calculation, we need 2 pi over the absolute value of w. So this would be 2 pi over 3 pi halves. So you multiply your outsides and you end up with 4/3. In this case, your pi's cancel. So remember, if your w has pi, your period doesn't. And if your w doesn't have pi, then your period does. So remember, in that respect, they are opposites. So our period is 4/3. Okay, the next one, this part's a little difficult to show. It has your matching graphs for this. You have all of these parts here, and you have different graphs. It goes up to J. So there are 10 graphs, and here's different functions. And what you need to do is write what I write, and then I'll show you what letter it compares to. Okay, so for 21, you get y equal 2 sine pi halves x. So it's positive, your amplitude's 2, and this period would be 2 pi over pi halves, which gives you 4. So the correct graph for that one, with amplitude 2 and period 4, can't be the one that says 4 pi, so rule out those, rule out these. Amplitude 2, period 4, so from middle to middle, that'll be F. This is on page 409. The next one we have is number 22. We have y equal 2 cosine pi halves x. So again, amplitude's 2, and our period is 4. Now, the sine graph that we just did goes through the origin. This one, since it's a cosine graph, goes through 0, 2. Not 0, 1, because our amplitude's 2. So we need to find one that starts high at 0, 2, but has a period of 4. Like this one goes at 2, and then there you go. So that was E. The next one, we have 2 cosine 1/2 x. So instead of pi halves, it just has 1/2. So again, this one's an amplitude of 2. It does go through 0, 2, but this time your period is 4 pi instead. So this is the A graph. So that's that one. Again, 0, 2. You can compare A and E like this. It's just this one says 4 pi, this says 4. So that's going to be A. Number 24. This one we have y equal 3 cosine 2x. So this time we go through 0, 3. And it's a cosine graph, and our W is 2, which means our period would be pi, because it's 2 pi over 2. So that choice is going to be I. It goes up to 3, and that's the graph. So our period from the high point to the high point, you could think is pi, or if you want to think from the low point to the low point, is negative pi halves to pi halves, which means it's pi. 25. This one we have y equal negative 3 sine 2x. So this reflects the x-axis, and it goes through 0, 0. It's a sine graph, and our period would be 2 pi over 2, which is pi. So this one, it's going to go through 0, 0, and then start going low after that. So that's going to be H. So it goes through 0, 0, then it's down, and then it's back up. So that's H. (26). This one we have y equal 2 sine 1/2 x. So this one goes through 0, 0, and the period would be 2 pi over 1/2, which gives you 4 pi. So one of the longer periods, and this would be the B graph. So it goes through the origin and 4 pi. For 27, this one is y equal -2 cosine 1/2 x. So this has to go through the point 0, -2, since it's cosine, and the period would be 4 pi. So this one matches the C graph. It goes through 0, -2, and period 4 pi. Number 28. This one is y equal -2 cosine pi halves x. So again, going through 0, -2, but this time our period would have to be 4 instead of 4 pi. So that's the G graph. Compare the C graph to the G graph. They both start low at the origin, and this one has 4 pi, this one has 4. Number 29. This one we have y equal 3 sine 2x. So it does go through 0, 0, but your amplitude's 3, and your period would be 2 pi over 2, which is pi. This makes it the J graph. Goes through 0, 0, has a maximum at 3, and pi halves is an x-intercept, and so is pi, which is 4 pi halves. This one has a period of pi. And number 30, this one is y equal -2 sine 1/2 x. So this one does go through 0, 0, and it reflects the x-axis. And the period would be 2 pi over 1/2, which is 4 pi. So that's the D graph. There's your D graph, which goes from 0 to 4 pi, and maximum is 2. Okay, so there's those 10 questions. The next one we have is number 31. This time we have the computer-generated graph from the calculator. Notice a couple of these go to 8 pi, a couple of them go to 2 pi. So you have to look closely at your maximums. And we're choosing from these 4. Is it 3 sine? Is it -3 sine 2x? Or what? Okay, so all of these 2 are positive, so that'd be one of these. And these 2 are negative, so it means it's one of these. Okay, so here's the work for it. We have y equal 3 sine 1/2 x. So like on all of these, our amplitude is 3, but in this case, our period would be 2 pi over 1/2, which gives you 4 pi, which means it's A. So it's the very first graph. on this one, 32, we have negative 3 sine 2x. So this one's reflected, the x-axis, and it's 2 pi over 2, which is pi. So this one, it's negative, and it's going to be c. So A and C. The first one, again, positive, had period 4 pi because there are 2 periods worth shown. And on this one, it's period pi because, again, 2 periods are shown. And so that means 33, which is positive 3 sine 2x. That's going to be positive, and it's B. And on 34, y equal negative 3 sine a half x is reflected. A, B, C, D. Okay. Now we have a couple of graphs. You may need to pause this and pick it up tomorrow. Just depends on where you are. Okay, so we're going to continue doing these 3 graphs. This one is y equal 3 sine x. Our amplitude's 3, our w is 1, our period is 2 pi. So that's just the original. Now what you notice on your graph paper is it goes from negative 2 pi to 2 pi. And so it's showing 2 periods worth. So again, it's sine, so we start here at the origin. Our amplitude is 3, and we have plenty of room for that. So at the next spot, it's higher, then middle, and then low, and then back to here. So remember on this, make it smooth, not pointy. So there's 1 period worth. So just continue to here and then back. And again, try not to make it like triangles. So this particular ordered pair would be 3 pi halves comma negative 3. Okay, the next one, number 40. This one says y equal sine 3x. So our amplitude's 1. Our W is 3, and our period would be 2 pi thirds. So it's a sine graph, so we know it starts at 0, but since our period is 2 pi thirds, instead of 2 pi, we need to cross out some numbers. So this furthest one over here, instead of being 2 pi, is going to be 2 pi thirds. 2 pi thirds. So what we want is we want our graph to generally look like this, and then down, and then at this one down, and then back up. The problem is those aren't the exact values, so we want to count by pi 6. Two pi 6, which means pi thirds. And now this one, instead of 3 pi 6, would be pi halves. And then this one would be 4 pi 6, which is really 2 pi thirds. So an easy way to remember it is if our period is 2 pi thirds, then this one has to be pi thirds 0, and this was 2 pi thirds 0. And then the pattern just continues over here. So let's just cross these out and continue the pattern. So this would be negative pi 6, negative pi thirds, negative pi halves, and negative 2 pi thirds. Those are the x's. Any questions? Okay. Then our last one for the video, number 44, this shows y equal 2 cosine 1/4 x. Now, since it's a cosine graph, we know it's going to go through 0, 2. And we know our w is 1/4. We have to figure out our period. 2 pi divided by 1/4 would give you 8 pi. So what that means is we change this 2 pi to be 8 pi, and then split it in half, gives you 4 pi. Split this in half, gives you 2 pi. And then this 2, 4, 6, 8. Okay, so that's going to be the pattern. You can use your concept of a half or taking the middle every time. And let's see, if we're going up to 2, we don't have problems counting by ones. So start at 0, 2, and then it comes down at 2 pi, and then even lower to negative 2 for our y value. Then it bounces back up at 6 pi, and then it's back to normal at 2. And then just continue the pattern. Remember, if you wanted to use different colors or pencil, you can, but that's what we're looking for.